Hi everyone, this video is going to walk you through how to find length of a planar curve, also known as the arc length of a curve. So we're going to look at the curve y equals 1 over 12 x cubed plus 1 over x over the interval 1 to 3. So let's take a look at it first so we know exactly what we're talking about. So in blue you see the curve, and you'll notice I have the x values 1, 2, and 3 marked off. What I have highlighted is the length of that curve that we're trying to find, just so you have a visual of what it is we're doing. So in order to do this, the first thing you'll need to know is the formula for how to find the length of a planar curve. This is definitely one you will want to have memorized. And the formula states that the arc length, or the length of the curve, and we use the variable s to represent that, is going to be the integral from a to b of 1 plus, and you need to take the derivative of the function in question, square it, dx. So that's the formula you'll want to have memorized. These often show up in the multiple choice section of the AP exam. For our purposes, I'll be having you work some of them out by hand. And that's why I wanted to walk through this video so you can see exactly what's going to be required of you. So doing these, really we're just going to find the derivative by hand. It's good practice since we haven't done that in quite a while. So the derivative of this one would simply be 1/4 x squared. And if you think of this as plus x to the negative 1 and do the derivative of that, we get that's negative 1 over x squared. So to find the arc length, we're going to be doing, in this case, the integral from 1 to 3, 1 plus, and that derivative that we just found squared, dx. And really from there, we're going to do it in our calculators to generate the answer. So let's turn to our graphing calculator and we'll walk through what that looks like. So if you bring up your blank work screen, we're going to do Math 9 for your integral, and we're doing the integral from 1 to 3 of the square root of 1 plus, now this is where we need the derivative that we found. And remember, we're going to have to square it. So I'm going to use, instead of 1/4, I'll just use the decimal, a little easier to type, x squared minus, and it's 1 over x squared, remember, so I'm going to do x to the negative 2. Right, so there's your derivative, and remember we need to square it, so it looks like that. Definitely check over how you type it in, because as you can imagine, if you have a typo, it will mess up your answer. And there's your answer, 2.83 repeating, easy, done. That's really the end of the problem. Of course, there's a lot of different ways you can use some of the built-in features of your calculator to make this even easier. If this was strictly a multiple choice question and you did not want to run the risk of doing that derivative wrong, remember one thing you could do is if you have your equation, your function under y1, remember you can set up y2 to find the derivative of that which you have under y1. Remember, you can do Math 8, and we're doing the derivative with respect to x of what we have under y1. It looks like that. And we want over all x's because we essentially want like an equation for the derivative. You don't want a numerical derivative. You're not looking for the derivative at one particular x value. So this is how you'd want to have it set up. And if you turn back to your quit screen and go through setting this back up again, it'll be the integral from 1 to 3 of the square root of 1 plus. Now this is where you want to call up that derivative, which remember would be under y2. So you can simply do vars and bring up y2, square that, so it looks like that. And of course you get the same answer. So that's an option if it really is just a pure multiple choice question and you really don't want to run the risk of accidentally finding that derivative incorrectly. Let the calculator do all the work for you. For the problems in which, though, I'm asking you to show me some work, I am going to ask you to find that derivative by hand. So as we found, that answer ends up being 2.83. Repeating, remember, the other option is to have it approximately 2.833. Remember, your answer needs to be accurate to the nearest thousandth according to the AP standard. And that would really be all the work otherwise you have to show. So I hope this helped give you a little bit of guidance in terms of what's going to be expected of you for these problems.